I've generated this contour data set from the 2017 LiDAR data collection for Baxter State Park and Katahdin Woods and Waters. Here is our highest elevation value. There's Baxter Peak right there. Our highest contour is 5,260 feet. The peak itself is 5,267. So that appears to be correct. We're happy with this. And now this 10-foot contour interval is pretty dense. I'm going to want to display these lines as very, very light, faint, thin lines that will barely show up on the map. But every 100 feet or 1,000 feet, I want a much darker, bolder line. So that if I'm really looking for this detail of 10-foot contours, I can find it, but I can have a quick visual reference to the 100 or 1,000 foot intervals. I could create two new data sets, one for 100-foot intervals and one for 1,000-foot intervals, but that would take up a lot of space, and I can choose how I want to display, or if I want to display different intervals, if I have an attribute here that is whether it's a 10-foot, 100-foot, or 1,000-foot interval. I'm going to have to do this in a two-step process. First, I'm going to have to convert this into text so that I can use a wildcard operator in a SQL query. And then I'm going to select, based on those query results, anything that ends with a 0, 0. So if it ends with a 0, 0, it's a 100-foot interval. If it ends with a 0, 0, 0, then it's a 1,000-foot interval. So we'll create our first new field, and I'm just going to call this text, because all we're doing is converting our elevation from an integer type to a text type, upon which the wildcard operator that looks like a percentage sign can be used. So we're going to deselect there. Now we can right-click on the header text and use Field Calculator. And we can say that text equals, double-click, elevation in feet. Okay. Good. So now we have a new column, and this is exactly the same as our elevation in feet, only instead of an integer format, it is now text. Once this blue wheel of death stops rolling around, I'm going to create another new column, and that new column is going to be called interval. And that is going to say whether it's a 10-foot, and all of these are going to be 10-foot, or whether it's a 100-foot or 1,000-foot interval. I'm going to just stop displaying that so it stops slowing us down. So add another field. Short integer is fine. It's going to be 10, 100, or 1,000. We're going to call it interval. Okay. Think. Good. So now we are going to select by attributes. I'll start this over. So where text, double click, is like, single open quotations, the wildcard, 0, 0, close single quotations, apply. So what this is doing is saying anything in this column text, doesn't matter what it starts with, but if it ends with 0, 0, we're going to make that selection. And we've done that, so if we scroll down, we see 5200, 5200, 5100, these have all been selected. So now if I calculate a field value for the column interval, it will only apply to the selected features. So right click, Field Calculator, and for those selected features, the interval is going to be set to 100. So anything that ends in 00 is 100. But this one ends in 000. This is a 1,000-foot interval. So we can just add another 0 into our query here. Text like starts with anything but ends in 000. Apply. So now we've got much fewer selected here. We can do the same thing. Right click, Field Calculator, and now we're identifying the 1,000 foot intervals. Now I've gotten ahead of myself here, and I've got all these zeros in here where I want these zeros to be 10s. These are all 10-foot interval contours. So now I'm going to do another query where interval equals 0. That's going to take a minute because there's a lot of zeros. Alrighty, so now we've selected the zeros, but not the 100s and not the 1,000s. So now I can do another right click, field calculator, interval equals 10 foot. Okay. Good, so now we have a column that shows whether the interval is a 10 foot, 100 foot, or 1,000 foot interval contour. Deselect everything, and now we can go into the symbology of this data layer and say display by categories, where the field is interval, add all values, selecting from an awful lot. They're all tens, hundreds, and thousands. Uncheck all other values, we don't have any in the count. So the 10-foot contours, we can make that a light gray with a width of 0.1. 100 foot, we can make black with a width of 1. 1,000 foot, we can make black with the width of 2. Okay, okay. Let's turn this back on. So now we have our thousands, our hundreds, and in between our tens. And this is just displaying a rough preview. Let's go ahead and export this map and see what it looks like as a polished final product. And that is a fine looking map. If we were to print that out at this kind of scale, we could measure exactly the elevation as we were going along. We could adjust the width of these, zoom in, zoom out. If we wanted a data set that was just the hundreds or the thousands, we could do that by going into the attributes, because if you were making a map that was more zoomed out than this would be too much detail. We can go into our table, slowly, surely. Select by attributes, such that the interval equals 100 or the interval equals 1,000. Apply. There we've made our selection, right click, data, export data. I'm actually going to save that to "100-foot contours." Okay. And that's given us a new data set that we can display like the old one according to its interval, so 100s and 1,000s. We only have hundreds and thousands now. Choose black with a width of 0.5 for hundreds, and black with a width of 1 for thousands. Let's go ahead and zoom out. Close this. Now if we're to export that map, it's more zoomed out than the first. And there's our map with 100-foot contours with the 1,000-foot contours in a bolder, thicker black.